Today we're going to start Chapter 7, which is we're going to be studying exponential functions. Some of these exponential functions and rules you've learned in a previous math course. So some of this is going to be review, although some of it will probably be new. There are 11 different examples here on page 1 of your notes. You should have your notes out called Exponential Functions, the packet that I gave you today. And down the left-hand column are the names of all of the rules, but it's not important that you know the names of the rules. They just each have a name. And then this middle column gives a generic example of how to use each one of these rules. And then over on the right-hand column, there are specific examples of how these rules are used when we encounter them in a problem. So first of all, we have something called the multiplication rule, and it goes like this. If you have the same base, these bases both have to be, whatever they are, they have to be the same. They can be x or y or 3 or anything, but as long as the bases are the same and you multiply these two terms together, you will have to add those two exponents to get a simplified result. So x to the a times x to the b is x to the a plus b power. The specific example is if you have a to the 4th times a squared, you're going to get a to the 4 plus 2 or a to the 6th power. The second example is the opposite of the multiplication rule. The division rule goes like this. If you have the same bases and you're dividing these two terms, then what you do with the exponents is subtract them. So this would be x to the a minus b power. And a specific example, these bases, like I said, can be numbers or they could be variables. So if you have 3 to the 5th divided by 3 to the 4th, the final result would be 3 to the 5 minus 4 is 3 to the 1st. And 3 to the 1st, you don't write it like that, you just write it as a 3. The next rule is called the power rule. If you have a variable or anything raised to a power and then the entire thing is raised to another power, what you're going to do is you're going to keep that same base, it's an x, and these two variables, a and b, are going to be multiplied together. So x to the a power raised up to the b power is x to the a times b. So our specific example is a to the 4th squared is, you're going to multiply these two exponents, a to the 4th squared is a to the 8th, 4 times 2. And these rules are all very similar to each other, so you just have to think about them carefully before you go ahead and apply them in a problem. The power of a product rule says that if you have if you have three things or two or more things multiplied together, these are factors. If you have factors, not terms separated by a plus sign, but factors that are multiplied together, and this entire set of factors is raised up to some power, this is called a, then what you do is you take this a exponent and you apply it to every single factor in the parentheses. So this would be x to the a times y to the a times z to the a. The a gets applied to everything as long as it's not a plus sign in between, which would make these terms, and they're not terms, they're factors. So this specific example, a lot of people forget to raise the first, if you have a numeric factor, a lot of people forget to raise the numeric factor up to this exponent, but this 3 gets raised to the 3rd power, and so do the a, b, and c. So this becomes 3 to the 3rd times a to the 3rd times b to the 3rd times c to the 3rd. And we usually don't leave it as 3 to the 3rd power because 3 to the 3rd is 27. So this simplified completely would be 27 a cubed, b cubed, c cubed. The next rule is power of a quotient, which is similar to power of a product. If you have a quotient, anything divided by each other, raised to the a power, you're just going to place the a power on both the numerator and denominator, as long as they're not terms. So we have, this is x to the a divided by y to the a. And again, this 3 exponent gets applied to the 3 and to the a and to the 2. Don't forget to apply to every single factor, or if this is a quotient, to both the numerator and denominator. So this is 3 to the third times a to the third all over 2 to the third. And like I said, we don't leave 3 to the third or 2 to the third because they're small numbers. You can evaluate them. 3 to the third is 27. So this is 27a cubed all over 2 cubed, which is 8. So that would be the final simplified answer. A zero exponent. Anything raised to the 0 power, and you can pull your calculators out and you can verify this. Take any favorite number of yours, 10 or 20, anything raised up to the 0 power is equal to 1. So for example, 9,999 raised up to the 0 power is equal to 1. No matter what, anything raised to the 0 is 1. But you have to be careful, because if you have a coefficient in front of something that's raised up to the 0 power, if you remember PEMDAS, the order of operations, it says that you apply the exponent before you do the multiplication. So in this case, you have to apply the exponent onto the x. So this is x to the 0 power. That gets done first, which is going to be equal to 1. And then you're going to do the multiplication, which is a times x to the 0, which is 1. So a times x to the 0, which is 1, a times 1 is equal to a. So in this example, if you have 9,999 times x raised up to the 0 power, well, this is 9,999 times 1, which is 9,999. The next example is if you have a negative exponent. A negative exponent means you're going to take the reciprocal of this base. So x to the negative a is the same thing as the reciprocal is 1 over x to the power of a. So for example, if you have 3 raised up to the negative 3 power, you're going to have 1 over, the reciprocal of 3 is 1 over 3, and this is 1 over 3 raised up to the 3rd power. A negative exponent becomes a positive exponent when it moves to the denominator. So 3 cubed is 27, so the simplified answer would be 1 over 27. A negative exponent never means that the result is going to be negative. It means the result is going to be a fraction. So we should add that to our notes. It never means the result is negative. It means the result will be a fraction. So add those to your notes. If you have a fraction raised to a negative exponent, you can look at this a couple different ways. You can apply the negative a onto the x and onto the y, and you can call this x to the negative a over y to the negative a. But the easier thing to do is if you have a fraction raised to the negative power, what you can do, making it easier for yourself, is you can flip the fraction upside down. This becomes y divided by x, and the a changes from a negative to a positive. So if you have y over x to the a power, you're going to have y to the a over x to the a. So a fraction raised to a negative power, you are going to flip the fraction first. So our x over y became y over x, and then after you flip the fraction, you're going to change the negative exponent to positive, And then the last thing you're going to do is you're going to apply the a power to both the y, the numerator and the denominator. Okay, so if we have 3/4 raised to the negative 2 power, we're going to flip 3/4 upside down and call it 4/3. Then we're going to change the negative 2 to a positive 2. And then we're going to apply the 2 to both the 4 and the 3. So 4 squared is 16, and 3 squared is 9. So the result of 3/4 to the negative 2 is equal to 16 over 9. And if you wanted to pull your calculators out and in parentheses put 3/4, raise it up to the negative 2 power, and do a math frac on it, your calculator will give you a 16 over 9. So I just grabbed my calculator and I'm going to show you the example that we just went through, 3/4 to the negative 2 power on my calculator. So I'm going to hit my alpha y equals button to get 3 over 4, and I'm going to raise this whole thing up to the negative 2 power, and over here my calculator says 16 over 9, which is just the calculator flipped 3/4 and made it 4/3, and it took it to the second power. So 4/3 to the second power is 16 over 9. So you can check, if you have a numeric example, you can always check your work on the calculator. But the tricky part is if you have variables, you're not going to be able to do that checking on a calculator. But just that's just another thing to remember. That is a fraction raised up to the negative exponent is you flip the fraction, change it to positive, and then apply it to both numerator and denominator. All right, and then the last two are just additional rules about negative exponents, and this gets a little tricky. This is a little different than the previous example, because this negative exponent in this example, letter J, this negative exponent only applies to the x. It doesn't apply to the b, because this entire fraction is not in parentheses. If it were in parentheses, it would just be just like this example, but it's not. This negative a only applies to the x. So what I'd like you to do is anytime you have a negative exponent on a factor by itself, I'd like you to circle it and just draw an arrow, because it's going to move to the other side of the fraction. This b doesn't have a negative exponent, so this b stays in the denominator. So this x to the negative a moves downstairs and becomes x to the positive a, and because there's nothing left in the numerator, we're going to have to put a placeholder of 1 in it. So this becomes 1 over b times x to the positive a power. So the specific example here is we have x to the negative 3 in the numerator, so I'm circling that because it has a negative exponent. I'm drawing a little arrow to make sure that it goes to the other side of the fraction, and it's not going to have anything left in the numerator, so we have to put a 1 on top, and this becomes 7 times x to the positive 3. And then in the last example, if you have a negative exponent in the denominator, what you're going to do is you're going to circle it again like you did. Anything that has a negative exponent, please circle it and draw an arrow, because it's going to move to the other side of the fraction bar. So this x to the negative a moves to the numerator. It becomes x to the positive a, and there's nothing left in the denominator, so we could put a 1 under that and call it b times x to the positive a over 1, but usually we don't write a fraction that has a 1 denominator. We just get rid of that 1 and call it b times x to the positive a. So this specific example here, 7 over x to the negative 3, circle this x to the negative 3, draw an arrow up here, and this becomes 7 times x to the positive 3 over 1, but we don't have to put the 1 in there. So those are the 11 rules that we're going to have to work with. And a lot of times these rules are combined into single problems, and you'll see that with we're going to do the first few examples on this page. So we'll start with example 1. Our job is to simplify, and we can do these a number of different ways. I'll just show you the way that is most handy for me. So when I see y to the 4th times y to the 3rd, I'm going to think, okay, this is a multiplication rule, so I'm going to add those exponents. So I've got some room to work down here, so I'm going to write my work down here and then the final example on the line, or the final result on the line. So y to the 4th times y to the 3rd becomes y to the 7th. And on the bottom I've got a power rule, y squared cubed. I'm going to multiply those exponents, and that becomes y to the 6th. So step 1, simplify the numerator. Step 2, simplify the denominator, write it out, and then our last step is when we have this is a quotient rule, so we're going to subtract those exponents. Y to the 7 minus 6 is y to the 1st, which is just y. So our final result will be simplified down to y. Example number 2. You have a negative x to the 5th, which can't be simplified down at all because there's no parentheses here. But if you have a negative value, negative times negative is positive, and negative times negative times negative times negative is also positive. So any negative number, any negative variable raised up to an even power becomes positive. But in this numerator, there's no parentheses, so we're just going to leave it as negative x to the 5th power. In the denominator, this becomes a positive x to the 4th. And a negative divided by a positive results in a negative. And now we're going to subtract these exponents with the quotient rule. 5 minus 4 is 1. Negative x to the 1 is negative x. Example number 3. We have this power of a product rule from the first page. So this 5 gets applied to the x and the y both. So this becomes x to the 5th, y to the 5th. And in the denominator, look at the 3. The 3 is only on the y. It's not on the x because there are no parentheses like in the numerator. So this x just stays an x. It doesn't have the 3. And the y is y to the 3rd. So this denominator really didn't change at all. So now what we're going to do is because these are factors, there's no plus sign. If there's a plus sign, you couldn't do this. But with no plus signs in there, there's factors. So we can simplify the x's down. X to the 5th over x to the 4th, or x to the 1st is going to be x to the 4th. Y to the 5th over y to the 3rd is y to the 5 minus 3, which is y to the 2nd power. So we are actually subtracting each one of these exponents because the bases are the same, the bases are the same. So we have x to the 4th, y squared. Example number 4, we have a k exponent, and each one of these factors is going to, the k is going to apply to it. So this is going to be power of a product, power of a power, x to the 2nd to the k. You're going to multiply those exponents, x to the 2k, and then the k also is applied to the y. So y to the k. So that's all we can do with that one. X to the 2 times k, power of a power, y to the k. And remember, we can only do that because this is multiplication. If there was a plus sign, this rule wouldn't hold at all. Now we have an exponent that's negative. And a 1/2 x squared. Now if you have anything out in front of a fractional coefficient, this x squared can move to the numerator always, not the denominator but the numerator. So this really can be written as 1/2 x squared is the same thing as x squared over 2. So I'm just rewriting that, and I'm raising it to the -3 power. And if you remember from before, if you have a fraction raised up to a negative exponent, you're going to flip the fraction upside down, 2 over x squared, and change the negative to a positive 3. This 3 gets applied to the 2 and the x squared, so you have 2 cubed over x to the second to the third is x to the 6th. You're going to multiply because that's a power of a power. 2 cubed is 8. X to the 6th is x to the 6th. So we have 8 over x to the 6th power. That's one of the many ways to do this problem. On example number 6, we have the same base. The base is 2. And this is just a plain old product rule. Product rule says if you have the same bases, you are going to add the exponents. So you keep the 2 as a 2, and then you just add the exponents, x plus 4. You can't do anything else with that. Example number 7, we have 2 factors that have negative exponents. So like I said, there are many different ways to do this, but what I would do is I would take this negative exponent and I would move it to the denominator and call it x to the first. I would take this y is the only thing with a negative exponent, and move it to the numerator. And so what we have in the numerator is left with this y right here that I didn't touch. This y to the negative 2 moves up to the numerator and becomes y to the positive 2. In the denominator, this x to the negative 1 moved downstairs and became x to the positive 1. And then we also had this x, which stayed downstairs. So take care of the negative exponents first, and then use your other rules, your product rule in this case. Y to the first times y to the second is y to the third because you're adding exponents, and x to the first times x to the first is x to the second. And so that's our final simplified answer, y cubed over x squared. Number 8, we have 2 over 6. These are factors. That can be reduced down to 1 over 3. X to the second over x to the first. Notice how I'm circling these with the same bases. Okay, 2 minus 1 is 1. So x to the second over x to the first becomes x to the first in the numerator because the numerator has the bigger exponent than the denominator. And then the y's. This is y to the first over y to the negative 1. So what we could have done is we could have circled this y to the negative 1 and moved it up to the top and left this y to the 1 here. And this y to the negative 1 comes up top and becomes y to the positive 1. So I've moved this guy up here. And so what we have left is 1 times x times y, which is x times y squared over 3. And that's all we can do with that problem. Oh, and we forgot the 1 over 3. I forgot the 1 over 3. No, I didn't. X times y squared all over 3. That's 1/3, which was 2 over 6 reduced down. In example number 9, now we have some multiplication going on. This is just a plain product rule. What we have here is we have 4 times 4. These 4's get multiplied by each other, so 4 times 4 is 16. Now we have x to the second times x to the first. Oops, let me do the work down here in this white area. X to the second times x to the first is x to the third. And then y to the negative 4 times y to the negative 3. If you add those exponents, you're going to get y to the negative 7. And now it's not simplified if you have a negative exponent, so this y to the negative 7, you can put this whole thing all over 1, and this y to the negative 7 moves down and becomes y to the positive 7 in the denominator. So what we have in the numerator is 16x cubed, and in the denominator we have y to the positive 7. And I think we're about out of time. I've given you a lot to digest tonight. So if you want to try 10 and 11 on your own, you're certainly welcome to. We'll probably start out with those two examples in class tomorrow. Thanks.